Hello everyone, in this video I am going to solve a question related with Thevenin's theorem. The question asks, find the Thevenin equivalent of the circuit shown on the left to the left of the terminal A and B. Before solving the question, let me briefly explain what is Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source in series with a resistor. So, the circuit seen from this terminal A and B can be represented by its Thevenin equivalent model, which can be seen in figure B. Here, it has a voltage and a resistor. The important thing is that the circuit should be linear. What is meant by linear is that voltage and the current should be directly proportional to each other. Suppose that we have a circuit consisting of a resistor, independent sources, and a diode. Can we apply Thevenin theorem to this circuit? The answer is no, because of the diode characteristics. It has a characteristics like that. Since this is a nonlinear behavior, we cannot apply Thevenin's theorem to this circuit. To find the Thevenin equivalent of the circuit, we need to find Thevenin voltage and the Thevenin resistance. First, I am going to find Thevenin voltage, then the resistance. The Thevenin voltage is the open circuit voltage at the terminal A and B. That's why it's also called open circuit voltage, VOC. Since this part of the circuit is open circuited, there won't be any current flow here, so we can ignore this 1 ohm resistance. In order to find the Thevenin voltage, we can apply nodal analysis or mesh analysis. In this question, I'll apply mesh analysis. Both meshes are chosen to be clockwise direction, but you can choose counterclockwise direction. Let's call it mesh 1 and mesh 2. And if we apply KVL at mesh 1, so we follow this path and we come to 32 volt with a minus sign, so we just write minus 32. Then we keep going and we come to 4 ohm. The voltage across the 4 ohm is 4 times the current I1. Then we continue follow and we come across the 12 ohm. So the voltage across it is 12 ohm times the current above it, on it, sorry. So the I1 is going up, downwards, and the I2 is going upward. Since these two is not same direction, we should write I1 minus I2, and it should be equal to 0 since it's a closed loop. In mesh 2, it is easier than mesh 1, because let's say we continue to follow this path and we go like this and we came across 2 amperes, but the direction is not same, so there are no any other current, so I2 should be equal to 2 amps. But since the direction is different, opposite, so we should write minus sign here. If we substitute this 2 amperes to here, then we find that minus 32 plus 4i1 plus 12i1 plus time minus 2 amperes minus 2 amps, it should be equal to 0. Then I1 is equal to 0.5 amps. Then Thevenin voltage is actually the voltage across 12 ohm resistance, because this is Thevenin voltage and this is the ground. So Thevenin voltage is equal to 12 times I1 is 0.5 amps minus I2 is minus 2 amps, which is equal to 30 volts. We have found the Thevenin voltage. Now we need to find the Thevenin resistance. But we need to consider two cases. In the first case, we don't have any dependent source in the circuit, as it is in this question. So we just turn off all the independent sources. We short circuit the voltage source and open circuit the current source and remove them. So the rule is short circuit voltage source and open circuit current source. Then after removing the sources, then this is what's left. It's used for finding the Thevenin resistance, but from this terminal. So when we look at from this terminal, we see first 1 ohm resistance. So we just write 1 plus, then we continue follow this path, and the current can go here and here. Since there are two ways that current can go, this 4 ohm and 12 ohm are parallel. 4 ohm parallel with 12 ohm. This is equal to, of course, our Thevenin resistance, and 4 ohm with parallel 12 ohm is equal to 3, and 3 plus 1 is 4 ohm. This is the Thevenin resistance. Now we are ready to draw Thevenin equivalent of the circuit. This is the Thevenin voltage, 30 volt. Four ohm Thevenin resistance, and we connect it to the load from this terminal A and B. What if our circuit contains a dependent source? Then we should turn off all the independent source, but we cannot turn off the dependent source because it's controlled by another variable. So what should we do is that we can apply a test voltage from the terminal and we can solve accordingly. I'll solve question like that in the next video. Thank you for listening.